Hello, my dear students. So here again we have came with the with another numerical problem in electrochemistry, and in our previous class we have already discussed numerical problem on electrochemistry, and I'll provide the link of our previous tutorial in the description comment in the description box. You can find this class from the description box by clicking the link. So this is our present question. So the numerical problem says to calculate E0 cell for the following reaction at 298 Kelvin, and this is the reaction. So this is basically the full cell reaction. Okay, my dear student. So this is basically the full cell reaction. So what I suggest you, when you are given the full cell reaction, try to break this full cell reaction into two halves, at anode part and at cathode part. So what happened in the anode part? In anode part, oxidation occurs. That means aluminium, here aluminium from neutral aluminium, it becomes Al triple plus. So its oxidation state from 0 to triple plus, so it increases, the oxidation state increases. That means aluminium oxidizes. So this is the anode part. So how many electrons are transferred from Al to, so there are 3 electrons transferred from Al to become Al triple plus. So similarly, the cathode part, in the cathode part, copper double plus ions, after taking 2 electrons, it becomes neutral copper. After taking 2 electrons, it becomes neutral copper. So this is the anode part and this is the cathode part. So first of all, we have to equalize these 2 electrons. Okay, at anode part and cathode part, electrons involved in the cathode part and anode part. So multiply the anode part by 2 and multiply the cathode part by 3. In this way you can equalize the number of electrons, because the here the electrons involved is 3 and electron involved is 2, so it LCM is 6. So we have to turn this number of electrons into 6. So to turn this electron, to make this electron 6, we have to multiply this by 2 and this by 3. So when you have multiplied another part by 2, it becomes 2Al, to 2L, from 2L to 2L triple plus plus 6 electrons. Similarly, cathode part becomes, after multiplication by 3, it becomes 3Cu double plus plus 6 electron to 3Cu, this part 3Cu. Okay, so N is the number of electron transferred. What is the number of electron transferred? Number of electron transferred is 6. Okay, so if you add this part and this part, you get the full cell reaction. This is the full cell reaction. So look, if you add this part and this part, cathode part and anode part, you will get the full cell reaction. This is the full cell reaction. Okay, so this matches with our given full cell reaction. So from Nernst equation, so we applied Nernst equation on this full cell. So it becomes E cell equals to E0 cell 0.059 by 6. 6 is the number of electron transferred into log reactant by product by reactant. So eh, in the product part, in the product side, or in the product side, along with the aluminium, Cu also present, but Cu present in the solid form, so we omit the term Cu here, and we raise the aluminium concentration of Al triple plus to the power 2. Why we raise the power of Al triple plus to the 2? Because the stoichiometry of Al triple plus is 2, and we raise the power of Cu double plus to the power 3 because the stoichiometry of Cu double plus is 3. And here again the aluminium is in solid form, so in the reactant side aluminium is brought. Okay, so this is the E0 cell. So E0 cell, we have to calculate actually the E0 cell, and total actually E cell is given. So this is after rearranging this part, we can get the E0 cell equals to E cell. If what happened, E cell is 1.98 plus, because after rearranges it becomes plus. It gives the total equation, and the answer is E0 cell equals to 1.997 volt. So my dear students, I hope you will learn something out of this class, because such type of numerical problems are the matter of practice. Okay, the more you practice, the more you learn. Okay, my dear students, So if you do have any doubts, any queries, you can write in the comment section. I can help you as I can. Okay, my dear students. So stay tuned and please subscribe our channel. So meet you soon in our next class.